Alright, so simple machines. What is going to happen is simple machines are going to help us take work and divide it over a larger distance. So remember from the beginning, the formula of, let me go back to here real quick, work was equal to a force times a distance. So we're still going to apply a force. The difference this time is, though, is that what a machine's going to do, it's going to allow us to apply that work, and let me erase this, apply that work over a longer distance. So we're going to do the same amount of work. We're going to apply a less force, but we're going to take that force and apply it over a larger distance. Okay? Remember, this is the key. They do not allow you to do less work. You still have to do the same amount of work, okay? But you're applying less force. With simple machines, we don't have to push or pull as hard. In other words, we don't have to do as much, apply as much force, but we have to go a larger distance. Give me an example here. If you were to lift a car by hand, you wouldn't be able to, but you use a jack, you apply less force to the jack and you're able to lift that car in the air to change the tire. That's a perfect example of a simple machine. Okay? Simple machines can, if I go back to this. So the first thing simple machines can do is they can increase force. Simple machines can increase force. The second thing that a simple machine can do is that it can change the direction of force. So in this, as you look at it, what's going on here is the force of this barrel is up. But what happens is that force is divided up into this pulley system, and actually this guy is pulling down in that direction. So it makes it easy to pull less force to lift a larger amount of mass. Now, with simple machines, there are 6 types that we're going to look at: levers, pulleys, wheel and axle, inclined planes, screw, and wedge. You know what all these are, and each of them has a certain part. So we'll start with a lever. A lever is a bar, think of it as a straight, flat plane, okay, like a ruler. And it pivots around a fixed point, and that fixed point is called fulcrum. So as we look at, there are 3 classes of lever. There is a first class lever, a second class lever, and a third class lever. So as I said with the lever, the key is the fulcrum. So in a first class lever, the fulcrum is in the center. In a second class lever, the fulcrum is at the end. And in a third class lever, the fulcrum is at the end, but the difference is the load is at the other end. In the second class, the load was in the middle. And you see some examples here. So the wheel bear is an example of a second class lever. Tweezers are a perfect example of a third class lever. The next one we're going to look at is a pulley. A pulley is a wheel with rope and chain, or a cable running along a groove. So as you look at a pulley system, okay, as we said, pulleys, they don't necessarily change they're going to change the input force, but what they do is they change the direction. So there is mass being a force going downward in this direction, okay. But what happens is these pulleys allow us to pull in a different direction here. And it allows us to go through different things. The more pulleys you have, the easier the machine is. In other words, the less work you have to put into it. I'm going to start to go quick. The third one is wheel and axle, which is a shaft or an axle attached to the center of a larger wheel. So we can turn the wheel and go through. Okay? An example of this, when you look at your bicycle. Let's see, that pulls up. There we go. When you look at your bicycle here. There we go. So the gears in a bicycle. The wheel is the gear. The axle is the rod that goes through the center of the gear. So again, what we're talking about is this is the wheel right there, and then the axle runs through the center, like so. The next one is a inclined plane. And what an inclined plane does, it allows us to reduce the amount of force to do, so we are able to raise it a certain distance. So again, if we look at it, we're a force, and instead of going up, what we're doing instead is going over. So it's like a ramp. Think of it as a ramp. The next one is a screw. Is simply an inclined plane wrapped around a wheel and axle. Just like this. Imagine the grooves of the screw as the incline and the wheel and axle. Okay? As we continue on here, the next one is a wedge. A wedge allows us to change the direction of the. So as you look at the direction of the force, down, so it's going down. What happens is in this picture, the force is down onto the wedge. The wedge is here, and it's going down into that wedge and splitting the direction and go this way. Okay, so those are the simple machines.